Introduction. Generally, wireless networks consist of low-capacity links with nodes that rely on batteries. An efficient communication scheme for such networks should minimize both congestion in the links and control information in the nodes. Security is a critical parameter in wireless applications, and any efficient communication scheme has to integrate security vulnerabilities of the system in its implementation. Unfortunately, existing schemes have network security implemented at the upper layer such as the application layer. Meanwhile, parameters such as congestion, which affect data throughput, are the physical layer. Hence, any attempt to increase the security level in a communication system greatly compromises data throughput. The authors developed a metric to estimate a timeframe for cyberattacks using the RSA public key cryptography. In the analysis, the authors estimated the attacker's human time in carrying out a successful attack based on the key length. Such an implementation at the upper layer will curb any security attack at the prescribed time, but will greatly compromise data throughput at the physical layer due to the huge modular exponentiation involved in its implementation. The authors developed a secure and efficient method for mutual authentication and key agreement protocol with smart cards. The implementation, which is based on the constant updating of the password, will involve a considerable amount of control information, which is detrimental to the optimum functioning of the nodes. Research work using different information theoretic models to develop physical layer security based on the characteristics of the wireless links has been carried out. However, the existing methods for implementing physical layer security under the different information theoretic security models is expensive and requires assumptions about the communication channels that may not be accurate in practice. Hence, any deployment of the physical layer security protocol to supplement a well-established upper layer security scheme will be a pragmatic approach for robust data transmission and confidentiality. It is in this light that a new cross-layer approach is presented in this research. Major research efforts have targeted cross-layer implementation of security schemes in wireless networks. In this research, the proposed cross-layer security scheme uses signal processing techniques as well as efficient coding and well-established cryptographic algorithm to implement a security scheme, which greatly enhances security throughput trade-off, and curb many security threats common to wireless networks. The rest of the lecture is organized in 8 subsequent sections. In Section 2, we present the background knowledge required for the design and implementation of the new cross-layer security scheme. This will involve a review of the different techniques used in the development of the new security scheme. The first subsection presents the implementation of the multi-level convolutional cryptosystem. This implementation involves the combination of subband coding and a new nonlinear convolutional coding. Next, a review of the residue number system, RNS, with brief description of the Chinese remainder theorem, CRT, is presented. We conclude the section with an overview of RSA public key cryptography. Section 3 presents the protocol for the implementation of the new cross-layer security scheme. The FPGA-based implementation applied to CDMA using the new layered security scheme will be presented in Section 4. In Section 5, cryptanalysis of the cross-layer security scheme will be carried out in order to quantify the security. Quantification of data throughput is performed in Section 6, while different security threats which could be circumvented by the cross-layer security scheme are presented in Section 7. We end the lecture in Section 8 with conclusions of our work.